So, hi all. So I'm Amit Goel, a PhD student. So with me I have Gurjovan, he is an MTech student. Sundaram, he is again a PhD student. And Akash, Dipali and Saurabh are all helping us. They are also MTech students. So we'll be covering the basic security fundamentals. So the basic part that we would be covering today would be the attacking mode. So the topics that we'll be covering is the first of all we'll cover the password cracking. So this is when we have an access to the machine. So when you have an access to the machine, then how would you crack a system? You will use password cracking techniques. Then if you do not have an access to the machine and you are on the network, then you will be using man in the middle attack. Then we have SSL stripping and certificate forgery when the traffic is HTTPS. So man in the middle attack alone cannot track the password and the or the information. Then we'll require that SSL and the certificate forgery. And then we'll also cover the denial of service attack. And I'll also briefly cover the IP tables. So the main motivation of the talk is to cover the various attacks that we can do and see how we can prevent them. So password cracking, the first one. So how many of you have ever tried to crack the Windows or a Linux password or a Windows machine's password? Fine, quite a few. So which softwares did you use, kind of?
We use rainbow tables also.
Right, that is one of the things. And that is what we are exactly doing today. So, right. So the first thing is, if we have to crack so as we all know that the password will be stored in a hashed form, right? So one of the ways is that you store all the hashes and along with that you store all the passwords. So that way the table will be very huge, right? So the space complexity will be too high, or the other approach is that you calculate all the hashes at runtime and you apply the brute force technique, right? So that will be taking too much time. So the midway is the rainbow tables. So what is the midway? So what is a rainbow table? So yeah. So if we see this example, what we do in a normal scenario that so this say Wikipedia is the password and this is the corresponding hash to the Wikipedia. Then next is secret. So the corresponding hash is this, right? So if we are doing it through the brute force attack, then we will be storing each and every one of them in the table, right? That way the space complexity will be very high. Now, when we are doing using the rainbow cracking, what we'll do is, first of all, the very first thing is Wikipedia. Then the hash will be the corresponding hash that is calculated. What we'll do next is we'll form a reduction function which will take you back to the plain text. Now what is this reduction function? If we see the next slide, yeah. So this is the plain text, you get the hashes. This is the first approach. Then from this plain text, you go to the hash form and when you reduce it, you come back. You do not come back to the same point. So what kind of reduction functions we can assume? Say for example, when we have a plain text, then we find out a reduction function. The reduction, after applying the hashing, we get say ABCD 1, 2, 3, 4, 6, 7, right? So what can be the reduction function? That is say the first 6 alphabets in the hash that we calculate. So that is a one-way hash function. You cannot get back the same. You cannot get back the same plain text from this hash function, right? Is this clear? So then we move back. So what we do is for some of the passwords, we calculate the hash function, then apply the reduction function. So this is again a plain text, then apply again the reduction function, and so on. What we will do is, we'll only store the first line and the second less line. So how much saving did we achieve? We only stored Wikipedia and this corresponding hash. We did not store all these hashes and the passwords. And if we store this Wikipedia and this V0 $x, then say if the chain length is 1000, we are not storing all those 1000 passwords, that we will calculate at the runtime. So this is a compromise. So the compromise between the space complexity, we have reduced the space complexity a bit instead of taking all the hashes, and we have increased the computational a bit. So it's a midway between the two approaches that we discussed earlier, right? So why it is called a rainbow? So each and every chain can be considered as a rainbow. So kind of this. So now, so there are different so how the reduction is done. So there are different reduction functions. These reduction functions should be, so one way is to use all these reduction functions as the same reduction function. Say I'll take only the first 6 characters, I'll only take the first 6 alphabets, first 6 numbers, and each reduction function can also be different. So if we, so it has been mathematically proved that if we use different reduction functions, then the coverage is high and the probability of collisions is low, right? So if the two chains are approaching, to the same, say this chain gets divided over here, so there is a collision. In that case, it will be difficult to detect the password, right? So there are collision detection techniques, removal techniques, but better is you use different reduction functions, and the more different reduction functions you use, the more number of, the better is the coverage, and the better and lower is the table size, right? So if you want to get to know the mathematical details, I'll share the link with you. So basically, so for our purpose, what we basically require is, so we discussed this, so this is the plain text, this is the hash, you get back to this, and what are the hash tables, you get back to the plain text, and then you keep on going, and so you'll only store the starting point and the ending point.